Hello guys, in today's video we are going to discuss the solution of the problem trail of ones. So let us look at the problem statement. The problem statement says that given a number n, find the number of binary string of length n that contains consecutive ones in them. Since the number can be very large, return the answer after modulo with 10 to the power 9 plus 7. So let us try to understand the problem statement with the help of an example. So in this example, n is equals to 2. That simply means we want to count the number of binary string of length 2 such that it contains consecutive 1. So for instance, in this case, when n is equals to 2, the possible binary strings are 0, 0, 0, 1, 1, 0, and 1, 1. Of these 4 binary strings, there exists only one binary string which contains consecutive 1, because of which we are returning 1 as our answer. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to solve this problem, what we are going to do is, rather than counting the number of binary string with consecutive 1, we are going to count the number of binary string that does not contains consecutive 1. And once we have this info with us, and let us say this information we are storing in a variable s, once we have this info with us, in order to get to our answer, all we have to do is we need to compute 2 to the power n minus s. And in this way, we will be able to compute the total number of binary string of length n which contains consecutive 1. Now let us discuss how we will be able to count the number of binary string that does not contain consecutive ones optimally. So let us discuss that. So let's take few examples in order to understand that. So let us say n is equals to 2. Now when n is equals to 2, the possible binary strings as we know are, so these are the 4 possible binary strings which we have, and the binary strings which does not contain consecutive ones, these are the 3 binary strings which we have. Now in this 3 binary strings, let us have some information and store that information in some variables a and b, where a contains the number of binary strings that ends with 0. So of these 3 binary strings, the number of binary strings which ends with 0 are these 2. So over here we are going to populate it as 2. Similarly, b array contains the number of binary strings which ends with 1. So of these 3 valid binary strings, this is the only binary strings which ends with 1. So because of which we are going to put 1 over here. Now once we have these information with us, let us see how we will be able to solve for higher problems. So in order to solve for n is equals to 3, what we are going to do is, let's take the 3 valid binary strings for n is equals to 2. So these are the 3 valid strings from n is equals to 2. So in order to compute the value of a is equals to 3, and what does a contains? Let me write down over here. Array a contains the number of binary strings which ends with 0. Similarly, array b contains the number of binary strings which ends with 1. So let's see how with the help of n is equals to 3 we'll be able to populate the value for n equals to 3. For n equals to 2, the number of binary strings which ends with 0 are 2, and these were the 2 binary strings which we had. So this is my binary string 1 and this is the binary string 2. These binary strings ends with 0. Since these binary strings ends with 0 and our objective is to calculate the number of binary strings which does not contains consecutive 1, because of which each of these 2 binary strings has 2 options. So the first option is it could have 0 and it could have 1. Similarly, these 2 binary strings have 2 options. It could be 0 and it could be 1. For the case where the binary string already ends with 1, we have just one option with it, which is it should be appended with 0 only. Because if we add 1 to it, that simply makes this string as 0, 1, 1. And then this string contains consecutive 1, which we want to avoid. Because of which, for the cases where the binary strings ends with 0, so let me write it down here. For the cases the ends with 0, we have 2 options. Whereas for the case where the binary strings ends with 1, we have just one option. For two options, we can either add 0 towards the end of the existing binary string, or we can add 1 in the existing binary string. For the cases where we have just one option, which is just we can add 0 towards the end of the binary string or towards the end of the existing binary string. And that is what I have done. So once I do that, now let us count what should be the value of A and B. Well, A of 3 simply contains the number of binary strings which ends with 0. So let us count the number of binary strings which ends with 0. This is 1, 2 and 3. So this will be equals to 3. And the number of binary strings which ends with 1, how many such binary strings are there? Well, this is 1 and 2. So over here, this is equals to 2. Now let's take a case where n is equals to 4. So for n is equals to 4, and let me just write down the values of A3 and B3. So the value of A3 was equals to 3 and the value of B3 is equals to 2. Now we already know that there exist three binary strings which ends with 0. So these are the three binary strings, and the prefix could be something, so it has some prefix. We don't really care about that, but these are the three binary strings which ends with 0. Similarly, we have two binary strings which ends with 1, and these are these two binary strings. Now we want to compute A4 and B4. Now as we know, with the three binary strings ending with 0, we have two options. It could be either 0 or 1. So these have two options. It could either be appended by 0 or 1. Whereas these strings have just one option, which is to append it with 0. Now, using this information, let us see how we will be able to populate the value of A4 and B4. So A4 is equals to the number of binary strings already we had. So these are the three binary strings which we already had. And with these three binary strings, since we have two options, either it could end with 0 or 1. So that simply means each of these three binary strings will have three valid entries, which is this. This will give me one valid entry, this is another, and this is another valid entry for array A. And these two strings, since it can only be appended by 0, because of which these two also will give me a valid string. A4 is equals to 3 plus 2. And if we see closely, A4 is coming from the summation of A3 and B3. Now let's look at B4. Well, B4, the only values or the only valid values for B4 or array B will come from these strings only, because anyway these strings are now ending with 0. So this is not a valid string for Bth array. So the valid values will come only from this, and which is this path, because of which B4 array is simply equals to 3, which is equals to A3. So what we are concluding from here? Well, the recursion which we are concluding from here is, in order to calculate AI, all we have to do is AI minus 1 plus BI of BI minus 1. And in order to calculate BI, this is equals to A of I minus 1. And this is what the recursion which we are talking about. And once we have this information, we will be able to calculate the number of binary strings which does not contain consecutive 1. So let's use this equation in order to calculate the value for n is equals to 5. Now for n is equals to 5, we already have computed the value of A4 and B4. And the values of A4 and B4 is, well, A4 is equals to 5 and B4 is equals to 3. So using this formula, what should be the value of A5? Well, A5 is equals to the sum of these two, so 5 plus 3, which is equals to 8. And B5 is equals to A4, which is equals to 5. And if you want to understand how we are coming to these conceptually, let's elaborate our understanding. So here A4 is equals to 5. That simply means that there exist 5 binary strings which ends with 0. So these are the 5 binary strings, and it contains some prefixes. And there exist 3 binary strings which ends with 1, and these are the 3 binary strings. Now let us see how many binary strings will end with 0. So here, since it ends with 1, so it has just one option, which is 0, to end with 0. So at least 3 binary strings. So in order to compute A5, we know that 3 binary strings, which are these 3 binary strings which will end with 0, plus Of these 5 binary strings, we have 2 options, 0 and 1. Similarly for all the binary strings. So 5 binary string which ends with 0 will come from here. So this is how this will be equals to 3 plus 5. And in order to compute B5, we need to count the number of binary strings which ends with 1, and the 1 will come from only these 5 binary strings. So this will be equals to 5. So that's the whole idea, folks. Now let us discuss the pseudocode for this problem. So let us say we want to count the number of consecutive ones, and an array is given to us and the length of the array is given to us. So the first thing which we are going to do is we are going to take 2 arrays A and B, and the size of these 2 arrays is n. Once we have these 2 arrays with us, we are going to populate our base case, which is a of 2 is equals to, so let's take the values of a equals to 2 and b equals to 2. So a of 2 is equals to 2 and b of 2 is equals to 1. So once we have this, now let us iterate on I in range 3 to n plus 1. And guys, one minor correction, this is n plus 1 and n plus 1 since we are dealing with 1 based indexing. Now let's proceed forward. Let us compute the value of ai. Well, ai, as we have discussed, is equals to ai minus 1 plus bi minus 1, and bi is equals to ai minus 1. And then once we have computed the values, we need to return the number of consecutive ones, so which is equals to 2 to the power n minus a of n plus b of n, and this is our answer. So that's the pseudocode, folks. Now let us see how we have implemented this in Python. So we are using 2 variables a and b, and the sizes we have defined it as such. Then the base case for a of 2 is 2 and b of 2 is 1. Then this mod, since the answer could be very large, and we have to compute 10 to the power 9 plus 7, which is this value. And then we are iterating from 3 to n plus 1. And we are computing the values of ai and bi. Over here, I have just put a mod operation since we have to perform the mod. And then towards the end, I am computing 2 to the power n minus an plus bn. And that is what we are returning. So that's the code, folks. Now let us submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.